Hello everyone. Today I will teach you about how to solve an ordinary differential equation in computer using Euler method. So first of all, let us have an ordinary differential equation of the form dy dx is equals to f of x comma y. And from the basic calculus, we know that we can approximate the derivative dy dx is equals to y at x plus dx minus y at x divided by dx. So where this dx tends to 0. In computer we will take a very small value for dx depending on the value of fx comma y, sorry. So in some advanced dx step we can approximate using our Euler method that y at x plus dx is equals to yx plus dx multiplied by fx comma y. So we can just calculate this formula from here. It is very simple. So as an example, we have taken this dy dx is equals to minus y, and to solve this problem we need some initial condition. So this initial condition is given here, that is y at x is equals to 0 is equals to 1, and our dx step is equals to the step size is equals to 0.1. So now using this y at 0 is equals to 1, we can just put it here that y at 0, then our dx is equals to 0.1, so we can get y at 0.1 using the value of y at 0. Now our y at 0.1 is equals to y at 0, that is 1 here, and dx is equals to 0.1 multiplied by f x comma y, and f x comma y here it is minus y in this example. So as y is equals to 1, so minus 1 it will be, so this is minus 1. Now using this formula we can get the y at 0.1 is equals to 0.9, and now you can just use the value of y at 0.1, that is 0.9 you have calculated. Now you can use this value in this formula again to calculate y at 0.2. So y at 0.2 is equals to y at 0.1, that is 0.9, plus dx is equals to 0.1 multiplied by minus y at 0.1, so this is minus 0.9. So using this formula you can calculate that y at 0.2 is equals to 0.81, and you can just do the same process again and again, and you can get your y at any x values. So now we will implement this in computer. So for this case I will use Python. So let me create a Python file, that is euler.py, and let me define the function fx comma y return minus y. So okay, the advanced method, that is I can just put x comma y and dx, three things there, then I can just write y is equals to y plus dx multiplied by f x comma y. and I can return this one. Yes, I can return this. So it is very easy. Okay. Now, what is my initial condition? Y is equals to 1 and x is equals to 0. This is my initial condition. Now let me just do for the one step, that is only dx is equals to 0.1, and let me just print the first x comma y comma dx. Okay. Now I have just made an advancement only for one step, so now it should give me 0.9. so just run it. Yes, it is giving me 0.9, but for which step? That x is equals to x comma advanced. Okay, so this is after advance, so this is dx, x plus dx. Okay, now I can just easily repeat it again and again. So for that case I can just write it like this. I can write a for loop, right? For I in range, let me just make it 2 steps. Okay, then I will get 0.81. so print x comma y, then advance, so y is equals to advanced, and x should be x is equals to x plus dx. Okay, so now in this case I am printing x comma y, then I am making an advancement by dx step, and then I am just advancing the x also, so that is x is equals to x plus dx. And now I can just see that, okay, for I can just also mention that this is x and this is y. Okay, so here I can see that at x is equals to 0 it is 1, then 0 at 0.1 it is 0.9. Similarly I can just then at x is equals to 0.2 it is y is equals to 0.81, and hence you can just calculate up to any number of steps, let's say 10 steps. Okay, so after 10 steps you are getting the x value, the y value is equals to 0.387, and hence you can just compute at any value of x. Y, you can calculate y at any value of x. So this is how you can compute you can solve your ordinary differential equation using Euler method. And actually for this case it is the solution is y at x is equals to 0 multiplied by exponential of minus x. So you can just also print another value, that is exponential of minus x. As y is equals to 1, y at x is equals to 0, that is 1. So just write it the exact. So this is the exact one, but exponential function is not um, accessible in, this is not a very general function. So for that we have to import numpy as np and just call this exponential function from np and then just check it out. Yeah, so now you can see that it is not exactly matching, but it is approximated and it is almost very near actually. It is 0.6561 and it is 0.67, and here it is 0.387 and it is 0.4. So how to resolve that? You can just make your step size smaller, then it will give you more accurate result. Okay, now you can see that it is at least up to three digit it is correct. Okay, so hence you can just decrease your dx and you can get more accurate results using Euler methods, but there are more accurate methods like RK4, RK2 and etc. So you can use them also, but for the time being this is the simplest one to solve an ordinary differential equation. Thank you.